Welcome. This is lecture number 18 of part 2. Actually, the concluding task for problems on equilibrium, this cylinder, contact surface, all. After this class, next class I am going for the most critical part of structural engineering, types of loads, support reaction, etc. Very, very important. Before that, I will upload one more information class. That is to tell how seriously you should study from now onwards. Okay, now. And more questions for this type of problems, I will think later. See, now, before starting, make a note. See, last class, we solved a question where these two cylinders are of different diameter. Then I told you, if they are same diameter, you are happy. So one question given for you to solve. So there, see, rough sketch. This does not look like a circle. Okay, rough sketch. Both cylinders are 100 mm diameter. Both weight are 4 kilonewton. This length given 170 mm. So therefore, this question given, I will give the answer for that one now. See, I will give the answer for that question. See, to solve the question, I don't require sketches solve. I will imagine. It is 170 by 100 is 70. 70 divided by 100, shift cos inverse, answer. The angle is, okay, answer equal to 45.573 degrees. Okay, then directly 4 divided by sine 45.573. You never bother what I am doing. See, here, between the two cylinders, the mutual reaction is 5.601 kilonewton. This mutual reactions. Then this reaction and this reaction both are equal to into cos 45.573. 3.921 kilonewton. Answer. 921 kilonewton. Same here also. Okay, same answer I told. 3.921 kilonewton. This I need not calculate. 4 plus 4, 8 kilonewton reaction. Solve this question. This is for you given as homework. Okay, now I will remove this question. Come to today's class. Okay, see. Today's class, don't see there. Question I am giving here. See, now this is a special type of question. This distance, how much I told? I set the question there. See, this distance is given 300 millimeter. Or one thing, 300 millimeter. Okay, now, two cylinders, bottom two cylinders are there. Above that one more cylinder is placed. Now, question is, for the given system, or two cylinders are placed on either side at the base, above that one more cylinder is placed. Data. The bottom two cylinders, both are, I am dictating, you should write. The bottom two cylinders, both are of diameter 175 millimeter. See, I wrote dia 175, dia 175. And weight of each of those cylinders are 10 kilonewton. This dia is 175. All words I am giving, weight is 10 kN. Dia 175, weight 10 kN. And the upper cylinder is of diameter 225 millimeter. This dia 225 and weight 16 kilonewton. Over. Find reactions at all contact surfaces. All surfaces are smooth. Okay. Question given. I will start. Solution. See, solution. I will start here. Be careful. I explained all this earlier. You should go back to previous questions of contact. See, every class and every question, identical explanation I cannot give. Therefore, I will dictate something now, right? See, what I will do is, this is a question given, don't touch anything. See, now, come here, or I write here only. This contact point, I will take A. This contact point, I will take B. This contact point, I will take C. Then, these two mutual contact point, I will take E. These two, I will take F. Okay. Now, at A, B, C, and this point is taken D. Okay, B, C, D. This contact point D. So when you apply the load this way, these two will go outwards. So there will be a reaction inward here, this I told you, smooth surface, outward reaction not see. If a smooth surface is there, when you press, inward reaction will come. This all I explained. So, see, I write here, let RA, RB, okay, RB, RC and RD be reactions from the surface on the cylinders at a contact point A, B, C, D. See here, RA, RB, RC, RD. Mark it here. Now, between these two cylinders, there will be a reaction. I use red color. See, upper cylinder, I am using red color for understanding. Actually, red color is not required. So, in the solution, I use red color. Okay. Between these two cylinders, some reaction. How? This will press it down. This, not down, this way. This will give reaction this way. Here, this cylinder will be pressed this way by upper cylinder. Then this cylinder will give reaction this way. So, for this cylinder, from that, you are getting this way force. See, this way force. For that cylinder, from these two, you will get this way force. See here. This is reaction R for cylinder 3 from cylinder 1. Reaction R for cylinder 3 from cylinder 2. This is action or transferred force or R only. R or you can tell reaction also for cylinder 1 from 3. R for cylinder, this is R for cylinder, this is R for cylinder, this is 1, 3, this is actually 2, 3. R for 2 from 3. Okay. R for 2 from 3. Okay. ABC. I don't know what happened there. 1 minute. Sometimes when I move here, camera gets disturbed. Okay, no problem. I should check those things. R for 2, 3. 2, 3. This all I explained earlier. Okay, now start. Little small, today's class not a big one. First see, this all I said, these values I wrote for setting the question. Okay. Now, consider free body of cylinder 3, not 1, cylinder 3. By mistake I wrote 1 because I first thought this is your 1. Now, very, very important. Those who want, make a note. When I consider cylinder 3, weight 1. One reaction here, one reaction here. Both are unknown reactions. So for cylinder 3, there are 2 unknown reactions. But for cylinder 1 or 2, one reaction here, one reaction here, one reaction from there. 3 unknowns are there. Sigma Fx0, sigma Fy0 or Lami's theorem if applicable. See, concurrent force system, only 2 basic conditions of equilibrium. Sigma moment is not considered here. Therefore, number of unknowns should not be more than 2. So, first you consider cylinder 3, solve and get these 2 reactions. Once you know the reactions, then you can come to cylinder 1 or 2 because then RA, RB, this reaction is already known. This I told last time. Okay, start. Write cylinder 3. See, weight 16 kN down. One reaction, see, this is for that cylinder, from this cylinder, see, reaction R31. This is R32. R31 is a black color to make perfect. R31, R32. Now, we want this angle, theta. Both are equal. How to calculate theta means, see, correct, clear now. This is 300. See, correctly what I am telling. This dia is 175. This dia is 175. 175 plus 175 is 350. I gave 300. Sorry, it is not 300. I should have changed the question. I first gave you 300. Now I am changing it. It is not 300. Sorry. It is a gap 125. 175. I first set the question for some other diameter. Change the question. 350 is sum of these two plus 125. 475. See, question changed because I first wrote this dia equal to 100, I think, mostly. When I set the question, I set for 100. Then later I changed it. So I forgot to change it. So this is given in the question 475. First of all, see, if it is 300 given, 175 itself is 350. How you can fit the cylinder? So therefore, okay, question changed. In the question, make it 475 millimeter. Okay, 475. See, this is 475. This dia is 175. This dia is 175. From 475, subtract diameter 175 twice. 475 minus 175 into 2 is 125 millimeter. You can make a note here how I got it. See, right here. 475 minus 2 times of 175 or 475 minus bracket 175 plus 175, 125. Now, see, this is O3, this is O1. Consider the point O3 here, red color point. Okay, red color is not required, O3. Correct it to O1. O1. Draw a vertical line and horizontal line. See here. We want this is theta, this is theta. If that is theta, this is also theta. Now, this distance is how much? This distance. You can see here. From O1, see here, correctly observe here. See, it is this radius plus half the gap. Radius is how much? 175 by 2 is 87.5. It is 175 by 2. That is this radius plus this is 125. It's half plus 125 by 2. That will come. I'm 35 plus 125 divided by 2 is 150. This is 150. See, correctly observe. See, if I light line mark here, see, this way. This is 475. This is half of 175. This is half of 1 minute before that one. 475 minus 175 minus 175, you got minus 250, you got 475 minus 350, you already got 125. Now, this is the radius. How much? 175 by 2. This is half of 125. So, 175 plus 125 divided by 2 is 150. This is this length. See, now, I'll do one thing now. To get theta. Okay. To get theta. Now we want this length. That length is sum of the radius of the two cylinders, cylinder 1 and cylinder 3. This cylinder is dia how much? 175. It is 175 by 2 is the radius of this cylinder and 225 by 2. 225 by 2 is the radius of that cylinder. This answer equal to 175 plus 225 divided by 2 is 200. This is 200. Okay, now this is theta. Therefore, right here cos theta equal to 150. By chance, if there is any calculation mistake, you adjust it. Sometimes what happens is some mistakes will come. You need not worry too much about those mistakes all. I think today World Cup semi-finals going on. I am just seeing what is the score there. India versus England. 150 divided by 200. So your theta will be 150 divided by 200 equal to shift tan inverse answer 36.87 degrees. 87 degrees. So I will do one thing now. I will come back here and write the answer. This theta, see, this theta equal to 36.87 degrees. Calculated value. Okay. This much is the most important. Now, very simple. 5 wickets. Okay. Now, this I will remove this sketch now. Okay, that can be removed. Not required. Okay. This theta calculations I will remove now. Not required. Now, see, how to solve? Use this sketch only. See, right component, up component, left component, up component. You can do one thing. You can make sigma fx equal to 0 and sigma fy equal to 0. You can do this way. Or you can use Lami's theorem. How? Then put the point here. This force is, see, this is one force here. There is one force here. This force, you should write like this. Then this angle equal to, see, 90 plus theta. 90 plus theta it is. 90 plus theta is how much? 36.87. 126.87 is this angle. This also is 126.87 degrees. This angle is, see, if this is theta, theta, 180 minus 2 theta. 180 minus 2 into 36.87 is 106.26. 106.26 degrees. This is what? This is your 16 kilonewton. This is your F31. I will not use red color, not FR. R31, R32. Either, you write Lami's theorem. See here, plus R31, if I go for what? Equilibrium, fx sigma fy, plus R31 cos theta minus R32 cos theta equal to 0, one condition. Then plus R31 sin theta plus R32 sin theta minus 16 equal to 0, second condition. Here, 16 divided by sine of this angle equal to R31 by sine of this angle equal to R32 by sine of this angle. You do whatever you want, get the value of R. Now correctly get the value of R, which are red color R will come now, red color R. You get from these two, okay, right here. Here I write. You can do whatever you want. R3 and R3. One of them is R31, other is R31, 32. Dash is not there. Okay. R31, R32 equal to. First of all, I should not explain all these things now. I'll give direct answer now. Actually, for me, that part difficulty is not there. I will do one thing. I will divide 16 by 2. Then I will divide by sine of 36.87. I got the answer. 13.333 kilonewton. 13.333 kilonewton. This also 13.333 kilonewton. Why you don't bother? I check once again. That is 16 divided by sine of 36.87 divided by 2. Yes, correct. Over. These are over. So we got this mutual reaction between cylinders. Now, what you do? See, now this reaction over. See, I already told you for this cylinder, if this is 13.333, for this cylinder, this is to be taken R13 of 13.333. This already I told you earlier. Now, you can consider either cylinder 1 or cylinder 2, left to your choice. Any cylinder will do. Both are same. Okay, I will consider cylinder 1. I will remove this sketch now. Shall I remove? Yes, I can remove this one now. It's not required. Now consider free body of cylinder 1. Now, red color is not there, black color. Okay, right. Okay. Consider free body of cylinder 1. See, if weight acting down, how much? 10 kilonewton. Then one reaction here, RA. One reaction here, RB. Not RB, RD. Okay, RD. RD. Oh, no, sorry. Here, this cylinder. RA. What is this? I don't know what is happening to me. See, that was seeing the score there. 10 kilonewton. And this is contact point, this reaction, RB. RB, RA, RB, 10. And then along this radial line, see, which makes an angle of 36.87 degrees for this cylinder, not this. See, this is the force for that cylinder. That is the force for this cylinder. A force acting this way. Now it is not red color, it is a black color. Okay, it is a black color. This force R for cylinder 1 from cylinder 3, which is equal to R13 equal to R31, right? R13 equal to R31 by mutually pressing each other equal to 13.333 kilonewton. Okay, now you can either apply equilibrium condition or Lami's theorem. Okay, first I'll do equilibrium condition. If you apply equilibrium condition, now you can solve. Apply equilibrium. Okay, sigma fx equal to 0. See, I will not write because this is not first time. Maybe 100 time I am explaining. Plus RA minus 13.333 into cos 36.87 equal to 0, you will get the value of RA. This, see, if you cannot do this much, if you are so lazy, I can't do anything. So 13.333 into cos 36.87. RA will come 10.666 plus 10.667 actually it is. Kilonewton, actually 667 it is. Actually giving 666, okay, 666. I don't like it because it is actually 667, okay, kilonewton. Sigma Fy equal to 0 plus Rb minus 13.333 sin 36.87 equal to 0, you get the value of Rb. How much it is? 13.333 into sin 36.87 is 8 kilonewton plus 8 kilonewton over. Or you can do one thing, see, you can apply Lami's theorem. Put Ra this way, put Rb this way, both are incoming here. See, Rb this way, so this force you take what? See, this force is already known for you. This is R13 equal to 13.333. This is all incoming, Rb minus 10. Now this angle you calculate, this angle you calculate, right, apply Lami's theorem, same answer will come. Okay, now lastly, I will present the answer and close this one. Okay, how much I got answer? Ra, Rb, R31. See, Ra I got here. Rb, you can make a note here. Due to symmetry, you can make a note one. Due to symmetry, your Rc here, your Rc will be equal to Rb and Rd equal to Ra. Or you consider once again this cylinder. I don't know. If I rub now, Ra came here. Okay, everything over. Okay, now I can put the answer here. Yes. Now therefore, the final answer is, I'll put the final answer here. No red color now. See, one cylinder here, little bigger. One more cylinder here, little out of scale. Okay, no problem. Don't bother about those things. One more cylinder here. Okay. This reaction is Ra. This point is A. Ra, see, there is a weight acting here, weight acting here, weight acting here. Ra equal to, where I got the answer? Ra equal to 10.666 kilonewton. So same here. This is D. Rd also equal to 10.666 kilonewton. There is a vertical reaction here. This point is B. Rb equal to 8 kilonewton. There is a vertical reaction here. 8 correct? 16, not 8. It can't be 8. Oh, sorry. It is not 8. One minute. 8 plus another weight is there, 10. It is 18. Oh, okay. I forgot the weight. Okay. You solve. You will get 18 only. When you put equilibrium condition, 18 only will come, not 8. Another 10 will come. See, I forgot that second weight. You solve, you will get 18. So, 10 plus 10, 20 plus, later 10 plus 10, 20 plus 16, 35 is correct. 18. So, this reaction is 18 kilonewton. This reaction RC also equal to 18 kilonewton, and see, weight is not required. Between these two cylinders and these two cylinders, this is for that cylinder, this force is, where is the answer? Where is that answer? 13.333 kilonewton. Same here, for this cylinder, force this way, for this cylinder, force this way is 13.333 kilonewton. Okay. Now, one check you can apply. See, if you forget everything, complete external outside equilibrium, this weight plus this weight plus this weight is 16 plus 10, 26 plus 10, 36, divided by 2, 18, 18. And how much this is pushed, same it will be pushed here. These two reactions are equal and opposite. Okay, now this question over. I am not told very slowly, etc., because this question, first of all, I should have given homework. Only thing is, I should have explained this is mutual. Still, I thought, let me complete the question. So with this one, I am going to close this additional questions for equilibrium. But still, there are plenty of questions are there. I will think a little later, and I may conduct classes for competitive examination where, and simultaneously prepare notes for competitive exam questions, objective questions. That time, or academic questions. That time I will consider our structural engineering knowledge point of view, this much is sufficient. So next class I am going for types of loads, point load, UDL, UVL, etc. Lot of things are there to tell. Then support reactions, and then calculating reactions for beams, determinate structures, indeterminate later. So before that, I will upload one more class informing all that. Serious part will be coming up from next class onwards. Okay, thank you.